Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Today we'll discuss yesterday's problem of the day, that was maximum depth of binary tree. Previously this problem has been asked in a lot of companies as well, like Amazon and Microsoft. So please give me a +1 in the chat, guys, if you can hear me clearly and everything is working fine. Then we'll start discussing the solution for this problem. Hi Rishit as well. So without further ado, let me share my screen and then we'll start discussing this particular problem. So I am sharing my screen now. All right. So my screen is visible. Thanks a lot, Jaydeep, as well. So let's start with this problem and let's see what the problem actually says. So the problem name is maximum depth of the binary tree. So basically we will be given the root node of a binary tree and we have to find the maximum depth of it, right? So suppose that if we have been given this particular tree, that is suppose we have one, okay, then for one you have a child 3 here, then you have a child 2 here, then you have a child 4 here, right? So in this particular case we can simply observe that we have to find the maximum depth, okay, and the maximum depth is defined as the number of node along the longest path from the root node down to the farthest leaf node. So basically if you will observe here, so what is the maximum depth? So from the root node, what is the maximum depth? Right, so you can see that the maximum depth is nothing but 3. Right here the maximum depth is nothing but 3 because 3 nodes are there, 1 2 3. So total the maximum depth is 3 because here the depth is 2. So we are considering the maximum depth. So on the right side the depth is maximum 2, on the left side the maximum depth is 3. So we'll consider the depth as 3 here, right? So you can see that for this test case the answer would be 3. Then if we consider the next test case, right, so in that case we have 10, then we have 20, 30, 40, 60 and 2. So we can observe clearly that on the right side if we see this path, that is 10, 30, 60 and 2, then in this particular path we are having the maximum length, because we are having maximum depth because we are having 10, 30, 60 and 2 on the right side. So basically we can say that it is having the length as 4. Is this part clear to everyone? Are the sample test cases clear to all of you? Like what do we mean by the maximum depth? Because in this test case you can see that the maximum depth on the left side is 3 and on the right side it's 4. So overall it is this much, it is 4 only. Is it clear to everyone? The sample examples are clear, guys? Then we can proceed further as well. Okay, so this much point is clear. Now what can we do, right? So basically suppose that if we are talking about a random tree, okay, so suppose we have one, then suppose we have two here, suppose we have three here, okay, suppose that we have somebody like 4 here, then we have 5 here, okay, suppose we have 6 here, then we have 7 here, okay, and suppose we have 8 here and we have 9 here. All right, so in this particular case now, whenever you have to understand one thing, if I have to find the depth, so what we can do is we can use the post order traversal approach. Okay, what do I mean when I say post order traversal approach? So whenever in a binary tree or in a binary search tree, you can say whenever in a binary tree I have to achieve something in order of n time, right? So whenever I have to achieve something in order of n time, why I'm saying this, because if you will observe now why we are talking about the post order approach, because suppose that if I am at this particular node, right, so which path am I going to consider? Please tell me, right? Guys, can I say that I'll consider this particular path, right? Because this is longer. If you will see, this particular path on the right side is longer, like it is having more depth compared to this particular path, right? So I am going to consider this particular path here, right? Amongst this, if this is the first path, this is the second path, so I'm going to consider the second path. So basically what I'm trying to say is we'll try to consider the maximum of the left or the right, and then based on that, so first of all we want the left result. Okay, so basically you can see that on the left side what is happening, on the left side there is one node, okay, on the right side there are two nodes, okay, so on the left side there is one node, on the left side there are two nodes. So which side you will take? You will say you will take this particular path, right? So basically you will, because it is having greater depth, and then when you will return, so you have the left as calculated, okay, left is having one length, okay, maximum depth of left is 1, maximum depth of right is what, 2. So when you are returning the result from the root node, then you are returning 1 plus maximum of left comma right, so 1 plus maximum of 2 comma 1, right? You are returning the maximum out of this. So basically you are returning 3 from here. Is that part clear? right? So basically what I require is, I can simply say that one observation is very clear, that we want the left subtree. Okay, we want the maximum depth of the left subtree. Okay, we want the left subtree depth. Okay, along with that we also want the right subtree depth. Okay, and then right subtree depth, and after that we will take the decision for the current root node. Okay, so basically this is what, when you have, when you are first of all calculating for the left subtree, then after that you are calculating the depth for the right subtree, and then you are making the decision for the root. Then this is what, this is known as nothing but post order traversal, right? Because first of all left root and right, so basically left subtree, right subtree, and then making the decision for the root. So this is nothing but, you can say, post order traversal approach, and it takes nothing but order of n time. Because what will happen is, we'll go down down down, and while we are backtracking, so then we are going to make the decision. So basically first of all the calls will be made for the left subtree and the right subtree, and based on their result the rest of the things will follow. So is this part clear to everyone, guys? Please write yes in the chat. Okay, why we will be using kind of a post order approach, right? So first of all calculating the left subtree, right, left subtree depth, and then calculating the right subtree depth as well, and then after that making the decision for the root itself. Is this clear? I hope that Prishit is also clear. So what will we do here? Whenever you will traverse, so when you move to the left, okay, so when you move to the left, so you'll observe that you will reach this particular node. So for this you will call on the left and the right. So basically when you will call here and you will call here, so these guys are going to return nothing but 0. Why? Because when you will call for the left and the right guy of 4, so they will return nothing but 0. So when you are going to consider the maximum out of the left and the right, so maximum of 0 and 0 is nothing but 0, so you'll return 1 from here, right? Then what happens from here, you are returning 1. Okay, and from the left side you are returning 0, so you'll take the maximum of the two, that is 1, and since this 2 node is also there, so overall you will return 2 here, because you can see this maximum depth is 2. Okay, then you will call for the right guy. Okay, then you will do what, you will call here, and from here you will get what in return. So when you will return from here, so you can basically see that this will return nothing but 1 here. Then you will go down down, right? So this is going to return 1, this is going to return 1. Now this guy is 0, so 0 plus 0 comma 1, the maximum of the left and the right is nothing but 1, and then you will return the root also. So basically this will become 2, 1 plus the maximum of the left and the right, so this will become nothing but 2. Okay, then when you have 6, so you can see that from the right subtree you are having the depth of 2, and from the left you are having the depth of 1. So basically what will you take, you will take the maximum, so you will take 2 plus 1 also, because you will take the current node 6 also, so this will be overall 3. Then from the then after that you can see that from the left side here the return value is what, from the left side we are returning 1, and from the right side we are having the length as 3, because the on the right side the depth is 3, so we'll return what, we will take the maximum, so maximum is 3, and this node 3 also we need to consider, so from here we'll return 4. Okay, then again you can see on the left side what happens, you have 2, and on the right side you have 4, so you'll take the maximum out of them, so you'll take what, you will take 4, and plus the this node as well, plus the current node. So 1 plus 1 plus maximum of 2 comma 4, so you will have 1 plus 4, that is nothing but 5, and you can see that the maximum depth is actually 5, right? Because if you will observe in this particular diagram, so you can see depth of 1 2, and then this is going to be 3, then 4 and 5. So yeah, maximum depth is 5. So is this much part clear to everyone, guys? Please write yes or no in the chat. Is it clear to everyone? So first of all what you will do is, you will calculate the result for the left subtree, then you calculate the result for the right subtree, and then ultimately what you will return is, you will return 1 plus maximum of the left subtree depth comma the right subtree depth. Is it clear to everyone? I hope that this much point is clear, and you can see that we are visiting each and every node exactly once. So in that case the time complexity in the worst case is going to be order of n only, right? And the space complexity will be only the recursive stack space that will be taken, right? So in this particular case what we can say here is that first of all we'll write the base case. So whenever I am iterating and whenever the root node reaches the null, so in that case we can say that we do not have any depth and we can simply return 0. Otherwise what we will do is, otherwise we can say that first of all we'll calculate the left subtree. So let me write L here. So left will otherwise in the L variable we'll calculate the maximum depth of the left subtree. So that way, for that we can simply call the max depth function, and we can pass the left node. Okay, so we'll call for the roots left here. Okay, so yeah, here what we are going to do is, we are going to call for the roots left, and then similarly what we will do is, we'll say that int r is equal to nothing but max and then depth. Okay, and then here we will call for the roots right. Okay, then after this part is done, so we will simply do what? We will simply return what? We'll return 1 plus, because we'll consider the current root node, maximum of what? Maximum of the maximum depth of either the left subtree or the right subtree, whichever is maximum, that we are going to simply return. So is this much part clear to all of you guys? Let me try and compile this code and check if it is working on the sample base cases or not. Okay, it is working because it is giving the answer as 5. Now let's try and submit this code to see if it gets accepted or not, guys, and then we'll be able to observe. Okay, so you can clearly see that this code is able to get accepted as well. And if you will see what is the time complexity of our approach, so since we are visiting each and every node exactly once, so the time complexity will be nothing but order of n. And if you talk about the space complexity, so if you'll consider the recursive stack space that is taken, so it will be order of n as well, space complexity. And if you have understood this problem till now, so please hit the like button and give me a +1 in the chat if you're clear till now, guys. Okay, now what I will do is also one more thing, which companies have asked this particular problem. So if you talk about the companies that have asked this problem, so primarily the companies are Amazon, Microsoft. Okay, I think Adobe has also asked this, but the primary two companies that regularly ask this problem is Amazon and Microsoft. Okay, so I'll just quickly copy this code for all of you and I'll generate the link so that you can have a look at this code on your own as well. So is it clear to everyone? I hope that it is clear, right, Rishit? You are clear with this? All right, so I'll just generate the link for this particular code as well, and then I'll share it. Okay, so now I will share this particular code in the chat also. All right, this question was very easy. And again, if I have to show you which companies have asked this particular problem, so the companies are nothing but Amazon, Microsoft, and Facebook. So primarily Amazon and Microsoft repeat this question a lot of times. Okay, and this is how this question will be done. Now somebody can say that the space complexity can be order of log n, that is the height of the tree. But actually in the worst case, what can happen is, suppose if you have a skewed tree like this, okay, if you have all the n nodes like this, then in that case the worst case is space complexity will be order of n only. So that is why I've written order of n here. Okay, so I hope that this problem was clear to all of you. Okay, and make sure to solve today's problem of the day as well. We'll be discussing today's problem of the day in tomorrow's live session, so make sure to join it, and make sure to hit the like button and comment understood if you have understood this particular problem and the intuition for this approach as well. Thank you guys for joining for today's session. The problem was quite easy, but it is regularly asked in Amazon and Microsoft, so make sure to solve it if you have not solved it, and we'll meet tomorrow with another problem of the day. So thanks a lot and keep coding, guys. Thank you, everyone.